Welcome to this next DeskPro2 tutorial video. It is about an application that many users will have dreamed about, scanning someone's head and then machining a small sculpture, a small statue. You see a few examples over here. These are all very small because our machine is only small, but when you have a larger machine you can go to a larger size, or even when you have a very large machine you can go to a very large size. Anyway, this is about how it is done. As said, many users will have thought about this idea, but it was prevented by the fact that a 3D scanner is needed, and 3D scanners are expensive, complicated, so far no 3D scans. However, recently one of our resellers, Sal Sabag, told me that he used the iPhone to do 3D scans for his medical application. The iPhone contains, newer iPhones have a feature called the Face ID, so when you hold your iPhone here it scans your face and then recognizes that you are the owner and unlocks the phone. So this uses a device called the True Depth camera, which is in fact a 3D scanner. So a number of applications have been developed. We did some research about the best application for this aim. We found the application EM3D, which stands for Ethan Makes 3D Scanner, and we found that it's a great application to do a 3D scan of a human head using your iPhone. It's not very expensive, unlocking just one. You can use the application free of charge. However, to export the result you'll need to buy a license. Unlocking one export format costs what is about $7 and unlocking all formats costs $20, so it's a very low cost application. My daughter has an iPhone of the new model, and she offered to install the app and scan me, and we'll see what happens. The scanning process is shown in the next part of this video. This is me ready to be scanned. On the left side of the screen you see the iPhone with the scanning app running. It shows exactly what my daughter sees while scanning. You need to press the button to start the scan and then hold the iPhone still for at least about 3 seconds, as explained here on the right in the scanning tips. The app needs that time to get the scanning process started and calibrated. Next, move the camera slowly and carefully around the head. The image on the iPhone is a great help. It shows you what has been scanned already, so simply paint the complete head green and you're okay. The image seems mirrored, however the resulting STL file is correct. You'll see that your first scan attempts are aborted by an error message telling that the app lost tracking, after which you need to start all over again. This video ends with the same error, however, as the scan had already been completely done at that time, the result was okay. Here is the lost tracking. And this is the result as shown on the iPhone, even with color information. It can be viewed from any side, as you can see, so this can all be done even without paying for the app. We paid, and for us the final step was to export the scan data to an STL file. Having seen that this Face ID 3D scanner works fine, I was of course interested to learn a bit more about how it works. Well, I found that the iPhone, the scanner, emits very thin beams of infrared light radially emitting from the scanner, and thus it projects points, small points of light on the face. The True Depth camera then captures those points and performs some magic to convert these to 3D coordinates. It will be clear that the closer you hold the camera to the face, the closer the dots are, so the higher the resolution of the scan. We found that the position of the camera for the initial scan, so when you hold the camera still for 3 seconds, that position of the iPhone sets the resolution of the scan. So the closer, the higher the resolution. On the other hand, the drawback is when you hold the camera close to the face, when you start, then the scanning process will be more difficult. When you start moving the camera, you quickly lose tracking. So you will need to experiment a bit to find what's the best setting for you. Anyway, we copied the STL file from the iPhone to my PC, and now I will now show you how to use Deskproto to create the toolpath. Let me first start Deskproto. Yes, here we are. It's the multi-axis edition. You need that for this project. And what I want to do, I start a geometry project as we want to process an STL file. The STL file is on our desktop. It's C number 7, and here it loads the geometry. You can see it from all sides. It's nicely detailed scan of myself. Okay, all the settings that we are going to enter. First, all part parameters, and the first thing I want to change is the size. As said, I have a very small machine, and otherwise Deskproto keeps complaining that it doesn't fit in my machine. The Y size, the Y size of my block is 50 millimeters, so that's a good scaling, and it needs to be rotated around Y to get it aligned with the rotation axis. So here 90 degrees, apply, here we are, and then I need to check the option use rotation axis. A number of message about details that will be changed. I'll leave that for what it is. I say apply, and I can immediately see that this is not what we need. Deskproto rotates the geometry around the x-axis as present in the STL data, and it seems like the cat 0 point is the location of the iPhone while scanning. So this is not what we need. We need a rotation axis within the STL geometry, and Deskproto has a nice option to achieve that. You can center the geometry. Here we are, this is better, and here we have our geometry nicely aligned with the x-axis. Perhaps the alignment that center geometry offers is not sufficient for you. In that case, there are more options to fine-tune this alignment, and I'll show the Deskproto website. Here it is on the website, in support, tips and tricks, using, and here we are positioning your geometry for rotation axis machining, and here you have a lot of tips to fine-tune that orientation and to fine-tune the position of the rotation axis. So you can look that up on our website for more details. Okay, back to Deskproto. Here we are, and we continue in the part parameters, and the next thing I want to set is the block size. Let me make a front view. Yes, because here on the right side I want to make the block a bit larger in order to allow the cutter to reach completely around the top of the head. Here's the material. I set it to custom. On this side a bit larger. My block is 100 millimeters, so I start at 6, now I have 100 millimeters, and the block was 50 millimeters around Y, and it is 70 millimeters around Z. So this is 50, this is 60, here we are, and you see that part of my shoulders and part of my back as well, you see that here will be outside of the block, but that's not a problem. The head is there, and most of the the important geometry will be there. Okay, that is the part parameters, and I continue with the operation parameters. First operation is for roughing, so I also call it roughing to make that clear. A 6mm bullnose cutter, that's okay. I want to use a skin of 0.5 millimeter to be removed while finishing. And as the wood is quite hard, I want to be careful in going down. My layer depth, the pass height, I will set it to only 6 millimeters. What more can be said? A distance between toolpath about 1.5 millimeter. This one a bit smaller to have sufficient detail. Feed rate may be a bit higher. 1200 millimeter per minute is okay. The strategy, I want toolpath around the rotation axis, so around A, but then I want around A reversed, because I want the cutter to start at this side and then slowly move back to this side, as here most of the block is connected to the rotation axis, so around A reversed. The area needs to be a bit smaller, because well, here are the scan is not complete here, so I want to start machining at 30 millimeters, and you can see here that is okay. Here this from 30 to 100 millimeters the scan is complete, so I can use that area to machine my sculpture. Further in roughing, borders is okay. Movement, well, the high chip loads I make it a bit smaller, as this is a hard wood. Well, that's it, no more things to change, so okay. Calculate toolpath, that's rather quickly, and here you see it goes down in a number of layers, 6 millimeters each. The block is rectangular, so only the corners are machined, and from the third layer it will go round and it machines down here completely to do the top of the head. So that's the roughing. And next, obviously, there needs to be a finishing operation, so I copy this one, copy the operation, I call it finishing. That's not good. So okay, and I want to finish with a smaller cutter, 2 millimeters diameter. Obviously no roughing here, so no roughing skin and no layers. It can be much more accurate here. Distance and step size both 0.12 millimeters. Feed rate can be a bit higher here, and especially the spindle speed needs to be higher for this thin cutter. However, on my machine I need to set the spindle speed on the machine. I cannot set that in software. The strategy also around A, but now it can start at the left side, and I want to use a helix toolpath. However, it's not activated here. That's because you will see here on the movement tab the cutting direction is meander, and I need to use either climber or conventional. I choose conventional, and now I can select the helix operation. Roughing, we went there. The area, well, same as for roughing, that's okay. Board is okay. Movement, well, everything is okay, so I can I get a warning about a multiple diameter cutter. However, as we have done a roughing operation first, that is not a problem. So I can calculate toolpath for the finishing operation, which takes a bit more time, as obviously a very long toolpath to be calculated with a pass distance of 0.12 millimeters. But it's almost ready quite quickly. Here we are. So I'll switch off the roughing by clicking on the lamp icon. This is the finishing, so it's one very long toolpath in a helix movement from minimum X to maximum X. So okay, that's the toolpath. What can I do more? I can show you a simulation of what the result will look like. And in order to get a nice simulation for this part, I need to
change the simulation resolution. I will make it a bit higher. Okay, and now I can select show simulation. It calculates the block. Here's the block. First I check the roughing, calculate, and that will take a bit of time, obviously, so will let the video run a bit quicker. And here's the simulation for the roughing. Well, as you can see, it looks indeed quite rough. However, all material has been removed except for the skin, which can be removed by this very thin finishing cutter, 2 mm diameter. And again, this will take some time, so I'll speed up the video. And here we are, the result, a nicely detailed sculpture of Mr. Lennings, and well, I'm looking forward to what it will look like when machined in wood. So I'll hide the simulation, back to the toolpath, and the final step in Desproto is writing the NC file. I call it test lex, and as you'll see, Desproto will write 2 NC files, one for the roughing, well, that was very quick, and one for the finishing. I can show you by again selecting this one for roughing, a small file, and one for finishing, and I will now take those NC files and proceed to the milling machine.
For this sculpture, I wanted to use a piece of light colored hardwood with allowing sufficient detail to have details in this very small sculpture. So I went to the Amsterdamse Fijnhouthandel to find a piece of wood, as they have a very large assortment of various wood types and various sizes. I found this beam of American maple, hard maple, called Esdoorn in Dutch, and I sawed a piece off and attached it to the rotation axis of my milling machine, as you will see in the next shot. Well, and finally the result. This is the small sculpture that I created. It's immediately clear who has been sculpted. The level of detail is not very high because obviously it's a small sculpture and I used a 2mm cutter. When you have a larger machine or a smaller cutter, you can achieve more detailed results. Anyway, I am very happy with this result. So I hope that you can do nice projects as well, and I hope that you can send us some photos of projects that you have done using this iPhone scanning process and the Deskproto 3D CAM software. Thank you for watching.